Okay, can you check again? Yes, ma. Can you see me now? Okay, check it again now because I just came up just moment before your call came in. Yeah, you can join me now. Just let me know on WhatsApp if you are able to join. Yes, ma'am. Okay, do I have somebody online? I'm still waiting for my two students. If you can hear me, please just type on the notification on the use the comment section and let me know if you are here. Okay. Please let me see your comments on the comment section if you're online. I think we have two students. Okay. I think my student is here. Ebong, I just saw your chat. You are welcome online. And I'm sorry for the stress, for stressing you this much. But we'll just see if we can make good use of this platform for today. And I believe that subsequently we'll make it better than what we have today. Okay. First and foremost, I will be going through the exercises or the assignment I gave you at the last class, where you were asked to do some exercises based on what I taught you at the last class. Thereafter, I shall take questions or reactions from you and those who are out there listening to this class. This class is meant for the GSS 2 students, and at the previous classes I gave you a rundown of the curriculum for GSS 2. Also, when I'm done with the exercises for today, I'll also get to know if you are able to finish the curriculum for the GSS 1. If you are not able to complete the curriculum, then we shall look at some of the topics that may be prerequisite to your understanding mathematics in JSS2. If you can hear me, you are also obliged to use the comment section and let me know if you are following the class or not. At any point in time that you feel you can't hear me again, you just let me know using the comment section. So once again, I'd like to know, can you hear me? Let me see you on the comment section. Also, you can chat me up on WhatsApp if you are not making use of your phone. If you have a separate device, you can also be using that to chat me up on WhatsApp. Okay, so at the last class, or let me say at the previous class, I gave you the curriculum for JSS1 and JSS2, where we said the curriculum for JSS2 divided into 6 themes, I guess, or 4. Okay, 5 themes, and these themes are broken down into topics. For the JSS2, your themes and topics are continuations of what you have in the JSS1 theme. So if you look at the JSS1 theme, we also have numbers and numerations, of which we are also having it in JSS2. Numbers and numerations in JSS2 is a continuation of what you have in numbers and numerations in JSS1, just like I said. So in JSS2, we'll be looking at whole numbers. But in JSS1, you also taught whole numbers, how to count in millions, billions, and trillions. In JSS2, you won't be counting, because at this point, we believe that you know how to count into billions, quadrillions, and all whatnot. So in JSS2, we shall be looking at how you can now play with these numbers. And under whole numbers, we said we shall be looking at whole numbers in standard forms, how to express these numbers in standard forms, because these numbers are said to be very big, which if you are to manipulate it in your calculations, it will look too cumbersome for you to handle, and you may end up making a lot of mistakes while using that. So it is best for you to know how to express numbers in standard form, not just larger numbers, but also smaller numbers in terms of 0.1, 0.2, fractional numbers, very minute numbers, especially for science students when you talk about carrying out experiments in the lab and all whatnot, because most of the experiments you do are said to be in minute quantity. After you must have done it in minute quantity, then you can put it in large scale quantity, which is in commercial quantity. So at the last class, I was able to explain to you whole numbers in standard form, how to express whole numbers in standard form, and I gave you a lot of examples how to express them in standard form and how they are arranged. So in today's class, we shall be looking at solutions to the assignment that I gave you. So I would like to know once again, can you hear me, please? If you can hear me, you just give me a thumbs up. Okay, it means you can hear me. Good. So in that case, I will then continue. So for the assignment, we're asked to express the following in terms of power of 10, of which you have submitted your workings, but they look too faint for me to actually see what you did. But I'm going to give you the solution to it. Thereafter, I shall compare it with what you did. And if in the course of me giving you the solutions, you can also ask questions on where on issues that you think you don't understand. So I'll be able to put you through. Thereafter, we'll then take turn for those in primary 4 or 5, as the case may be. So for the assignment, Let me get the black pen. We are asked to express the following in terms of power of 10. Just like I said, 10 is expressed in index form as 10 raised to the power of 1, while a billion is expressed as 1 or 10 raised to the power of, remember what I told you at the previous class, it is 1 raised to the power of the numbers of zeros you have after the first digit 1. So in this case, we have 6 zeros after the first digit 1. So in index form, this is said to be 10 raised to power 6, which in essence, we can say it is 10 multiplying itself 6 times to give us 1 billion. Okay, so this can be said to be 10 times 10 times 10 times 10 times 10 times 10. 1, 2, 3, 4, 5, 6. So this is what you multiply to give you 1 billion. I may not be doing others in this form, but rather I'll just be expressing them in standard form. Okay, so next is equal to 10 raised to the power of, count the numbers of zeros you have after the first digit 1. This is 3, 6, 9, 10. So this can be said to be 10 raised to the power of 10 in standard form. Number 4, we have 10 raised to the power of, let's do it together. This is 3, 6, 9, 12, 15. So this can be said to be 10 raised to the power of 15. And remember what I said in number 5, that anything raised to the power of 0 is 1. So 1 can be expressed as 10 raised to the power of 0. So this is what you will get when you are asked to express in standard form. For that of 6 to 20 to 15, did I actually ask you to do 6 to 15? Please reply me on the comment section. Were you asked to do that of 6 to 15? Let me know if it's a yes. Okay, you were asked to do that of 6 to 15? Okay, no. All right. I did that on purpose because I didn't explain expressing numbers that are lower than 1 in standard form. So that is what we shall do in today's class. So based on the assignment you did, do you have any issue with, do you have any question based on the first 5 that I just gave you? Is it clear to you? If it's clear, let me know. Miss Ebon. Okay, you are clear, right? Okay, so let's continue with today's class. So I gave you the assignments, and in today's class, we shall be looking at how to express numbers that are less than 1. Okay, so I will refer to them as decimal numbers. So we are going to look at decimal numbers. In the last class, all I gave you was whole numbers that are greater than 1. We look at 1, 10, 100, 1,000, million, billion, quadrillion, trillion. Okay, so in today's class we shall be looking at those numbers that are less than 1, and we refer to them as decimal numbers. So decimal numbers can be expressed in terms of powers of 10, and in this case the powers are negative. So if you have a number like 0.1, 0.1 can be expressed as a fraction as 1 divided by 10. That is to say, if you have an object or 1, if you are dividing it into 10 pieces, we refer to each of those pieces as 0.1. So in fractional form, it is written as 1 divided by 10. But remember, 10 is written as 10 raised to the power of 1. So this can be expressed as 1 times 10 raised to the power of negative 1. Negative because it is a fraction, and the 10 happens to be the denominator. So when you have 1 over 10 or 1 over anything, it is said to be expressed as a negative power. So 0.1 is expressed as 10 raised to the power of minus 1, because 1 times 10 raised to the power of minus 1 is still 10 raised to the power of minus 1. And because anything multiplied by 1 still gives you the same thing. Also, we have 0.01. 0.01 can be expressed as a fraction, and you were taught in JSS 1 how to convert from decimal fractions to proper fractions or to mixed fractions. So let's convert this to fractions, and thereafter we'll now express it in index form. So this can be written as 1 divided by 100. 100 in the sense that you move the decimal point 2 times, and this 0.01 becomes 1. 1 now divided by the number of times you moved that decimal point. So this is said to be, if you move it once, like in this case, when you move it 1, it is said to be divided by 10. But when it is moved twice, it is said to be 1 divided by 100. When you move it 3 times, it is 1 divided by 1,000. So this can be expressed as 1 divided by, remember when we're looking at whole numbers, especially whole numbers in standard forms that are greater than 1, we said 100 is expressed as 10 squared. So because 10 squared is at the denominator, this can be expressed in standard form or in index form as 10 raised to the power of minus 2. Now, this is only possible when the numerator is 1. I shall explain to you when it is not 1, when it is greater than 1, and you will see more examples on that. So if it is 0.001, where we have 3 decimal places, this can be expressed as 1 over 1,000, and this can be simplified further to be 1 divided by 1,000. Now in index form is expressed as 10 raised to the power of what? 3. And this in index form can be said to be 10 raised to the power of minus 3. So this is how whole numbers, decimal numbers are expressed in standard form. We also have more of them. Let me just write them out. This is 0.0001. 0.001 can be said to be 1 divided by, this is 10,000. Because when you move the decimal point, it goes 4 times. Okay? And this can be expressed as 1 divided by 10,000. Remember in our previous class, is said to be 10 raised to the power of 4. and this is equal to 10 raised to the power of minus 4. So this is how numbers less than 1 can be expressed in index form. So with this, you should be able to express any decimal number in standard form. Let's look at another number. For example, 0.123456781. So this can be expressed as, for you to know what the divisor is, count the numbers of zeros under it. This is 1 divided by 1, and the number of zeros under it determines the index value. So this is said to be 1, 2, 3, 4, 5, 6, 7, 8. So this can be said to be 1, 2, 3, 4, 5, 6, 7, 8. And remember, if you have to group them in terms of threes, then this is said to be 100 billion. And 100 billion is expressed as 10 raised to the power of 8. So this is said to be 10 raised to the power of minus 8. So this is how smaller numbers can be expressed in standard form. Now let's look at the exact assignment I gave. We shall then do that of 6 to 15, after which I will then leave some for you to try. So number 6, we have 0.1. For the meantime, or for your understanding, I will have to convert it from decimal numbers to proper fractions, and from proper fractions to standard forms. Subsequently, when you are done doing what I did, you can then convert it directly from decimal numbers to standard forms. Okay, so what I'm doing is just for you to understand better how it is being converted from decimal numbers to standard form. So 0.1 is said to be 1 divided by 10, and this is equal to 10 raised to the power of minus 1. Number 7, this is equal to 1 divided by 10 times the number of zeros, or 10 times the number of decimal places we have. And how many places of decimal do we have? This is said to be 6 places of decimal. So this is 1, 2, 3, 4, 5, 6. So this is going to be 1 with 6 zeros. 1, 2, 3, 4, 5, 6. And this is said to be 10 raised to the power of minus 6. So this is equal to 10 raised to the power of, now I have skipped writing it as fractions. You can then just go ahead to express it in standard form. So this is 10 raised to the power of minus 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 10 raised to the power of 9. So I would like you to give me the solution to number 9 to 12. So let me see your solution at the comment section from number 9 to 12. What do you think is the answer to question number 9, question number 10, question number 11, and question number 12? Then I will continue from question number 13. So let's go ahead. Miss Ebong, I'm waiting for you. What is answer to question number 9? What is your answer to question number 9? Okay, she said 10 to power 19. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Are you sure? Is it 10 to power 19? You have to check again. That's number 9. This is the one you're actually. I'm waiting for the answers. Okay. So solve number 9. You have to solve that of number 9. So I said count the number of digits you have after the decimal point. So if you count with me, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this is 10 to power minus 14. Sorry, this is minus 9. So this is minus 14, not minus 19, as stated. Okay, so let me see you do number 10. What's the answer to question number 10? Give me the solution to question number 10. This should be 10 raised to the power of what? I'm still waiting for question number 10. What is your answer? Answer to question number 10. Okay, 10 to power 19, that's correct. So this is, does it mean the answer you gave me initially for 9 was meant for 10? So this is 10 raised to the power of minus 19. Good. What about that of 11? 11 and 12? I want you to look at 11 again. I think you're missing it. You are wrong in number 11. Okay, hold on with number 11. Now, if you look at number 11, everyone listen to me. Number 11, remember, in the exercises or examples I solved, it was always in the first digit is always 1. But in this case, this is said to be 90,000. And 90,000 in a situation whereby the digit is not in terms of 1, 90,000 can be expressed as 9 times 10,000. 9 times 10,000. And 10,000 can be expressed as, okay, this can be expressed as 9 times 10,000 can be expressed as 10 to power 4. So this is said to be 9 times 10 raised to the power of 4. Okay, because 10,000 is greater than 1, so it is of the positive. But if it is less than 1, as in this case, then it is always minus of the negative. I don't know if that is clear to you. Did you get that? Okay. So, in that case, it therefore means that question 12 is equal to 4 times, question 12 is 4 million. And 4 million can be expressed as 4 times a million. So 4 times 1 million is equal to, remember, this is, I've already showed you how to express this in standard form. So this can be simplified to be 4 times a million. In standard form is said to be 10 raised to the power of what? 6. Okay, because we have 6 zeros after 1. So this is 10 raised to the power of 6. So in essence, 4 million in standard form can be expressed as 4 times 10 raised to the power of 6. Do you understand me, or do you have a question to that? Miss Ebong, let me hear you. Miss Ebong, are you okay? Okay, so if it is clear to you, then I will continue with the class. So, for question 13, this is a fraction, that is 3 divided by 100. And 3 divided by 100 can be expressed as 3 times 1 divided by 100. So this can be said to be a fraction. So I'm going to simplify this the way I did for others, and this can be expressed as 3 times 1 divided by 100 is expressed in standard form as 10 squared. So if this is 10 squared, multiplying it by 3, this is equal to, remember, this is a fraction, and therefore we said it's going to give us a negative power of 10. So this can be simplified to be 3 times 10 raised to the power of minus 2. So this is your answer. 3 divided by 100 in standard form is said to be 3 times 10 raised to the power of minus 2. I'll come again. 3 divided by 100 is equal to 3 times 1 divided by 100. Because if you multiply this, it still gives you 3 over 100. I then simplified the power of 10, which gave me 3 times 1 divided by 10 squared. Because 100 is said to be 10 times 10, and 10 times 10 can be expressed in index form as 10 squared. So we said, since 10 squared is at the denominator, expressing it in standard form is going to give us a negative power. And that gives us 3 times 10 raised to the power of minus 2. Is that clear to you? Okay, we move ahead. This is 8 divided by 10 million. So 8 divided by 10 million can also be expressed in standard form, same way we did question number 13. So this is expressed as this can be expressed as 8 times 1 divided by 10 million. So expressing 1 divided by 10 million in standard form gives us, first of all, rewrite that of 8. This is 8 times 1 divided by 10 million is expressed as 10 to power. What is the total number of zeros you have? This is 367, 10 raised to the power of 7. So expressing 1 over 10 raised to the power of 7 in standard form gives us 8 times 10 raised to the power of minus 7. So that is our answer to question number 14. So let's look at question number 15. Question number 15 says 0.000001 to be multiplied by 1,000. Now, when you have questions like this, you're asked to multiply two numbers. Already in JSS1, you were taught how to multiply whole numbers. But in this case, you are given powers of 10 to be multiplied as whole numbers. What you have to do is that you should first of all express both numbers in standard form before you can multiply. And this is how we do it. Express this in standard form, express this in standard form, and that will make it very easy for you to multiply. That is one of the essence of we expressing numbers in standard form. Why not just multiply it? But without the use of calculator, for you to do a good job, you must know how to convert these big and small numbers into standard forms for easy simplification. So expressing this in standard form, I will say move the number of zeros, move the decimal point to fall behind the first significant figure. So this becomes 1, 2, 3, 4, 5, 6. So I'm going to move. So this, in essence, is said to be 10 raised to the power of minus 6 because it is less than 1 times. This is 1,000. 1,000 is expressed in index form as 10 raised to the power of 3. So 10 raised to the power of minus 6 times 10 raised to the power of 3. This can be simplified, or this can be simplified using the laws of indices. Okay, so in essence, now I think that may look too big for you. So let me do it in a way that you will understand better. This I've already explained to you, that is equal to 1 divided by, this is 10 raised to the power of 6, right? But I'm going to write it as 1 1, 2, 3, 4, 5, 6. So this can be expressed as 1 over 1 million. So times, this is said to be 1,000, right? So this is also said to be 1,000 over 1. Now, multiply both the numerators and denominators together. This gives us 1,000 divided by 1 million. So dividing 1,000 by 1 million, you were taught that if you divide the numerator and denominator by 10, this goes out. Divided by 10 again, this goes out. Divided by 10, this goes out. So at the end, we are going to have what is left now be 1 divided by 1,000. And remember, we have already said 1,000 is expressed as 10 raised to the power of 3. So this is said to be 1 divided by 10 raised to the power of 3. And expressing this in standard form is said to be 10 raised to the power of minus 3. So therefore, 0.000001 times 1,000 is said to be 10 to the power of minus 3. So that is what you will get when you divide. So if you have any question, let me hear you out. Do you have any question? Mr. Bog, is it clear to you? Do you have a question? If it's clear, just comment clear. It's not clear. Okay, which of them? What question number is not clear to you? Let me know. What question number is not clear to you? Okay. So if it's clear to you, I'm going to give you an exercise to do, and you will submit it tomorrow. You're going to snap it and send to me. Now, I will want you to write the following in standard form. You will do question number 1 to 3. This should be your assignment. Ignore question 4 to 8. Let me see you do question number 1 to 3. Express them in standard form. Just follow the steps I took, and I think you will be on the right path. Although I'm going to send you more exercises to do. I'll give you more exercises to do, but for now, let's go ahead with this. I think that will be the end of our class for today. So let me know if you are done copying the question so that we can end the class for today. If you are done with the question, just write down, comment down. Let me know that you are through. Or rather, you can give me the solution. You can give me the solution to that question. So that when we come tomorrow, I will know that we have no assignment to be submitted and we'll just move ahead to the next subtopic. You can also share the link with your friends, and don't forget to like the channel before we call it a day. Miss Ebong, are you true? Let me know if you are true. Who else is true with solutions to the questions I gave? You can ignore questions 4 to 8 for now. Ignore it. When we are done in the next class, then we are going to solve that. But do you think you can attempt it? Question 4 to 8 is for you to express them in decimals, which is the opposite of what we have done. Okay? So you can leave it. Attempt it, but I'm not going to act on it for now. You can just look at it and try it on your own, but I'll say nothing about it for now until when I'm done with the next class. Can you give me your solutions? Give me your solutions to question number 1 to 3. I wish to apologize to my students on Facebook. This class is supposed to be for those on Facebook, but because of one issue or the other, we have to bring it back to YouTube. But subsequently, we'll look at how we can work it out so that both followers on Facebook and YouTube can benefit from the same class. Suja Kamaka, you are welcome. Oh, you are from India. Nice meeting you. This is a class for a mathematics class for those in junior secondary 2. So you are welcome. You are chatting from India. Nice meeting you. You can also help us to share the link with your friends and also inform them that we'll be having daily classes here on YouTube and Facebook. Okay. Nice meeting you. I hope you're able to get one or two things from the class. Were you? Okay, everyone, I'm waiting for you. Kamaka, you are right with your solutions. They are all correct. But the question is different from what you have on the screen. The question is for you to convert each of them in standard form, express them in standard form, not in decimals. So kindly express them in standard form. Express question number 1, 2, 3 in standard form. Miss Ebon, I'm waiting for you. I'm here to see your solutions. Mark, you're welcome. Okay, the class is meant for those in junior secondary 2. Very soon we'll move to another level where we shall be taking students in primary. Okay, Ebon, you said 3 times 10 raised to the power of minus 3. Okay, good. The first one is correct. Second is correct. The third is correct. Okay, yes. Yes, Ebon, this is 7 times 10 raised to the power of minus 3, while this is 10 raised to the power of minus 1, and this is said to be 3 times 10 raised to the power of minus 2. So I believe you got it right. So that is correct. Yes, Ebon, you got it. Mark, you should be specific. The answer you gave is to answer to question number 2. Okay, yes, that's correct. Okay. So in our next class, let me inform you on what we are going to be doing in the next class. In our next class, we shall be expressing whole numbers in standard form other than 10. other than the multiples of 10. Okay, so we shall be looking at how to express whole numbers or larger numbers in standard form, not just the multiples of 10. So you may be asked to express a number, for example, 1789 in standard forms. And we shall also try to look at smaller numbers, not just those in multiple of 10, like I said. So you may also be looking at numbers like 0.134567209. How can you express such numbers in standard forms? Just like I did in the previous example, where we have 4,000 and we are asked to express it in standard form. Now you know that 4,000 is 4 times a multiple of 4 times 1,000. So what you will do is to first of all separate both of them and then express 1,000 in index form. Then you multiply it by the multiple. So that is what we are going to do in our next class. So please, you can invite your friends. This class is going to run from 7 to 8, as we said. So it's going to be a 1-hour class for those of you in JSS2. Tomorrow, we are going to continue with mathematics, after which we'll also take a class for those in primary 4. So that brings us to the end of today's class. For those in JSS2, I would like to know how you feel about the class. Just use the comment section to express how you feel about the class. Let me know what you think. What should be done? Should we extend it? Should we bring it closer? Is it favorable to you? And I know most of you don't know, most of you were not aware of today's class. So subsequently, it will go viral. Okay, I'm going to give you a pre-knowledge or pre-information. I'm going to inform you prior to the class. So kindly like this video and also follow the channel if you are yet to do so. Also turn on the notification bell, okay, so as to be notified whenever we are holding our classes or whenever a new video is being uploaded. Now, at the end of every class or every video, there is always an assignment, and there's an award for you if you happen to be among the first 5 to submit your answers. So we need more followers. I'll advise that you share the link, share it to your friends on Facebook so that they can also follow this channel. And let me know in the comment section, what do you think about the class? Kamaka said he loved it. Okay, thank you very much. Thank you, I appreciate that. That's the positive feedback. Miss Ebon, what do you think about the class? Mark, let me hear your review. We have less than a minute to go. Okay. Miss Ebon, you love the class. Thank you, and do have a nice day. Yes, so we are going to be looking at mathematics for basic 4. Is Master Ebon ready for the class? Goodbye, Miss Ebon. Is your brother ready for the class? Let me know if he's ready. Is Master Ebon ready for the class? $9,000. This should be 10,000, 20,000, 30,000. This is 40,000, 50,000, We have 60,000, 70,000, 80,000, 90,000. Then we have 100,000, 200,000, 300,000, 400,000, 500,000, 600,000, I have 700,000, 800,000, and 900,000. Okay, Master Ebong, we shall be learning today how to count numbers, just like I said, up to 100,000. You must have been taught in primary, in your basic primary, how to count numbers from 1 to 10. And that grew from 10 to 100, from 100 to hundreds, into thousands. Okay? And it is expected that you have also learned how to convert numbers or how to count numbers from hundreds to million. So in today's class, or even in hundreds of thousands, okay, because this is just a revision based on what you have been taught. So I will just use this first class to revise what you have been taught under numbers and numerations. We have the normal counting numbers. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Up to 9, from 0 to 9. These are said to be single digit numbers. And because we are working with a base 10 system, we count in tens. On getting to 9, when you add 1 to 9, it gives you 10. And that grew from 10 to 11, 12, 13, 14, 15, okay, down to 20. From 20, when you add another 10 to it, it gives you 30. 30 plus 10 gives you 40. 40 plus another 10 gives you 50. So with this, you are able to count in tens. So repeat, or let's count this together. This is 10, 20, 30, 40, 50, 60, 70, 80, 90. These are said to be two-digit numbers. On entering 100 from 99, you have 100, and when you add up another 100 to 100, it gets to 200. So all these are said to be three-digit numbers. You have 100, 200, 300, 400, 500, 600, 700, 800, and 900. Any three-digit number is said to be is said to have the place value of 100. Remember, when we were looking at 1, 2, 3, 4, 5, 6, 7, 8, and 9, these are said to have the place values of units. because they are said to be single digit numbers. So they have the place value of unit. While this is said to take the place value of 10. Okay, so these are said to be tens because they have 2 digits. They are double digits. Getting to 3 digits, we have 100, tens, and units. Like I said, so this is a 3 digit number is said to be of the hundreds. When it gets to 4, we have 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000, 8,000, 9,000. This is said to be of the thousands. So we have this to be thousand, hundreds, tens, and units. So these are said to be the place values. In between 1,000 and 2,000, we have a whole lot of this. That is from the hundred, tens, and units. So any 4-digit number is said to be of the thousand. So I would like you to call out all these numbers. This is said to be 1,000. This is 2,000, 3,000, 4,000, 5,000, 6,000, 7,000, 8,000, and 9,000. Master Ebon, can you hear me? Master Ebon, are you still with me? If you can hear me, type yes at the comment section. Master Ebon, can you hear me? I'm waiting for you. If you can hear me, pick the call. Pick the call, Mr. Ebon. Okay. So I spoke about the hundred, tens, and units. That when you have digits, a 4-digit number, it is said to be of the thousands. So we have in that category, we have 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000, 8,000, 9,000, up to 9,999. These are said to be of the categories of thousands. Then, if it gets to 5 digits, it has gone to another level of thousands. So, while we have the first digit beginning from your right to be the unit, to have the place value of a unit, the second digit will have the place value of tens, the third digit is said to have the place value of 100, the fourth digit is said to have the place value of thousands, the fifth digit is said to be of the order of tens of thousands. So when there are 5 digits, we say they are of the categories of tens of thousands. When you have 1,000 in 10 places, it gets to tens of thousands. So this is said to be 10,000, while this is 20,000, 30,000. 30,000 will grow to 40,000, and when you keep adding 10,000 to it, it gets to 50,000, 60,000, this is 70,000, 80,000, 90,000. And from 90,000, it gets to 99,999. These are said to be of the order of tens of thousands. So a 5-digit number is said to be of the order of tens of thousands. Then, when you get to 6 digits, a 6-digit number is said to be of the order of millions. So this is units, tens, hundreds, thousands, tens of thousands, hundreds of thousands. So this is said to be of the value of hundreds of thousands. So tens of thousands grows into hundreds of thousands. So a 6-digit number is said to be of the order of hundreds of thousands. So we have 100,000, 200,000, 300,000, 400,000, 500,000, 600,000, 700, 800, and 900,000. So we shall do a little exercise. So let's look at this. Okay, Mr. Ebon, you are to count and complete these numbers. So I'm going to do the first one for you, and subsequently, you are going to do others. If you look at the first example there, you have 3 numbers given, and there's a missing number in between. So you are to give me the third number based on what you think have been added, or based on the difference of each of them. So I'm going to give you a call. You are going to call. You are going to read out the numbers for me, and then tell me which should be the missing number. Okay? So I'm going to give you a call at this point. I'm calling you. Pick the call on WhatsApp.
Hello, sir.
Okay. Master Ebon, can you hear me? Hello?
Okay, let me give it to him.
Okay, ma.
Hello,
Can he hear me?
Rob, can you hear him? He said he can hear you.
Okay, ma. Can you give him the phone? Because I'd like to hear him. I'd like to get a feedback from him. Yes. Sorry, ma. We are going to use a lot of data. Okay. Ralph, can you hear me?
Yes, sir.
Okay. Now, if you look at, can you also see your system? Can you also see the board on your system?
Yes, sir.
Okay.
Yes, sir.
So I'm going to do A for you. The question says we should count and complete. Now, there's a missing number there. What do you think is that number that is supposed to be here? So the first number under A is 7,507. Are you with me? Ralph, are you with me? We are still talking on WhatsApp.
Yes, sir.
Good. Don't end the call. Just hold the phone, and then watch your screen. The second number is 27,507. Right?
Yes, sir.
Okay. Now, if you look at the first and second number, you will discover that the difference between the first and the second is 20,000. Are you with me? Do you agree with me? Ralph, are you there?
Yes.
Okay.
Sir.
So what do you think will be the third number now? The third number that is missing. If 20,000 is added to 7,507 to get 20,000, it therefore means that you will have to add another 20,000 to 27,507. So the third digit or the third number now is going to be what? 47,507. So that the fourth number is 67,507. Did you get that?
Yes, sir.
Okay. So invariably what we have is that if you look at the first number, the digit before 7 is 0, right? Because there's no digit there. Then in the second number, the first digit is 2, right? Every other number is same as we have in the first number. Are you seeing it?
Yes, sir.
Okay. And
Yes.
And in the third digit, which I just wrote, the first digit is now 4. That makes it to be 47,507. Are you with me?
Yes, sir.
And the last digit, which is the last number, which is 67,507, the first digit is 6. So they are of difference of 2, which I will say it is a difference of 20,000. So the difference between each successive number is said to be 20,000. Are you with me?
Yes, sir.
Okay. Do you understand what I said in A? Do you understand what I said in A, Ralph?
Yes, sir.
Okay. So can we look at B together?
Yes, sir.
Do you observe anything in B?
Yes, sir.
Okay, what do you observe?
Sir.
Yes. Nobody should tell you.
Yes, sir.
Okay, look at B very well and
100
you say what?
and sir. 690.
Come again.
108, 690.
Are you sure? Okay.
Yes, sir.
Can you read out the first number in B for me? What's the number here? What number is this?
58,690.
Good. What is the second number?
78,690.
Good. What is the third number?
88,690.
Good. So what will be the fourth number?
The fourth number will be 100 and
No, stop telling him. Stop telling him. Let him look at it and get it himself. You can do it, Ralph. Let's go again. What's the first number?
the first number is 68,690.
The second number is what?
The second number is 78,690.
Now, what did you observe there? You observe that the first one is 6, the second one is 7, right? That's the
Yes,
first.
sir.
Good. The third one now is what? 8, right?
Yes, sir.
The third one is 88,690, right?
Yes, sir.
So what will be the fourth number? What do you think will be the fourth number?
Number will be sir.
I can hear you. The fourth number will be what?
What number will be 100 690.
No, that is the fifth number. Now, just listen to me, okay? The first number is 68,690. The second number is 78,690. The third number is 88,690. Then what do you think will be the fourth number? Listen again. The fourth number is 68,000, right? The second number is 78,000. The third number is 88,000. So what will be the fourth number? Now, if you observe, they keep adding. What? Is what? Okay, listen. The fourth number will be 98,690. So that the fifth number now is 108,690, because there is a difference of 10,000 among the numbers. The second number, for you to get the second number, you have to add 10,000 to the first number. They are moving in steps of 10,000. Did you get that? Did you get that, Ralph? Okay. Now let's look at the third. Let's look at the third question. Read it out for me. What's the first number there?
The first number is 68,003.
Good. The second number is what?
8,003.
Okay, that's the first number. The second number, what's the second number?
The second number is 78,003.
Good. And what is the last number?
The last number will be
That what?
38,003.
Okay. So the last number is what? The next number will be 88,000 and what? 3, right? So this.
I didn't get what you said.
Okay. I said what will be the third number now? Since the last number is 98,003, what is the missing number?
The third number will be 38.
88 what? Good. 88,003. All right. Okay. Now, D. I would like you to reduce the volume on your computer so that we use the volume on WhatsApp. Reduce the volume on your computer and increase the volume on your phone. Have you done that? Are you with me? Okay. All right. So D, the first number is 39,650, right?
Yes, sir.
The second number is what? What is the second number?
Number is 49,650.
Okay. And the third number is what?
59,650.
Good. So what do you think will be the fourth number?
59,650.
Yes, I'm talking about the fourth number now. After 59,650. Yes, say it. 69,600 and what? 50. So what will be the next number after 69,650?
79,650.
Good. 79,650. And the last number there is 89,650, right? Right?
Yes, sir.
Okay. So
Yes, sir.
read and complete E for me.
Okay, sir. 50,723.
Good.
That's the first number.
Good.
60,723.
Good.
That's the second number. 70,723. That's the third number.
Good. So what will be the fourth number?
80,723.
Good. 80,723. So what will be the fourth number now? The fifth number, sorry.
90,723.
90,723. Beautiful. What about F?
F is 97,700.
Okay. The second number?
Next number. 87. The second number is 87,700.
Good. The third number will be?
The third number will be 97.
Sorry? Your sister should stop telling you, okay? Let him try his best. Okay, go ahead. What will be the third number? I can still hear her talking. They have to stop whispering.
No, sir, she's not here.
Okay. Okay.
87.
Now, what can you say about the first and the second number? Are they increasing or they are decreasing?
They are decreasing.
They are decreasing, right? Good. So what will be the third number?
Yes.
What will be the third number now?
The third number will be 77,700.
Good. 77,700. Okay, so what will be the fourth number? The next number.
1,700.
Pardon, I didn't get that.
67,000.
So this is 67,700. Okay, good. And the next number will be what?
57,700.
Beautiful. 57,700. Okay, now the aim of this exercise is to enable you to count in thousands. Okay, in tens of thousands. Okay, and you have done well on that. Now I'm going to give you an assignment. I'm going to give you an assignment. So look at the board.
Yes. Okay.
So you have to copy and complete. You have to copy and complete this. The first on my list will be $179, $279, $379. You have to give me the next numbers that follows up to 2000. Did you get that? So if the first number is 179, the second number is 279, and the third number is 379, what will be the fourth number? What do you think will be the fourth number? Pardon? I didn't get you.
What was the first number?
This is 179. And the second number is 279. The third number is 379. Now I'm asking you, what will be the fourth number?
The fourth number 479.
Good. And the fifth number?
579.
Okay. So you have to continue with those numbers until you get to 2079. Let me end it with 2079. So you will stop when you get to 2079. Do you understand that?
Yes, sir.
Okay. B. You will do from 1011. The next number will be 1111. The next is 1211. The next is 1311. I'd like you to complete it to 2011.
Can you call the number?
The first number under B is 1000. Can you see it on the board?
No, sir, I'm not cutting it on the board.
Okay, is it there on the board now?
Yes, sir.
Okay, that is for B. Okay? So you will copy it from the board and submit it tomorrow, okay? Yes, so you have to complete it under this comment section, okay? So just look at it from the board and complete it. Do you have any question on numbers from 1 numbers running into hundreds of thousands? Is there any question you like to ask me? Because I'm going to give you exercises on that. Do you have a question on that?
No, sir.
Okay, so just copy what you have on the board and then let me have them tomorrow. Yes. You have to put it on the comment section. Okay?
Yes, sir.
All right. So that will be all for this night, and we'll continue from there tomorrow. Okay?
Yes, sir.
All right.
Good night, sir.
Good night. Okay. For other viewers out there, that is my interaction with Raf, who happens to be one of my online students. So I'll just give the assignment on the board. You are to copy and complete. This is to enable the younger ones to master numbers into hundreds of thousands. Okay, and it enables you to learn how to count in tens, in hundreds, in thousands, and thereafter we'll go into millions as you proceed to the next class. But for the purpose of this class, we are going to be limiting our learning to hundreds of thousands. So I'm going to be writing some figures out. You are to copy and complete it for me. Okay, so I'm going to leave you with this assignment. You are to copy and complete. And let me have your answers under the comment section. Thank you for being part of this class. This is going to be a daily class. We are going to be having this daily to enable the younger ones to do better in mathematics. Kindly like the videos as you watch, and if you are yet to subscribe to the channel, kindly click on the subscription button and also turn on the notification bell so as to be notified whenever a new video or a new class session is to be held. Also, you can share the link with your friends and family so that they can also benefit from this class. You can also do us a favor by using the comment section to let me know where you're chatting from or where you're viewing us from and how you feel about this class. We shall also be introducing classes for those in other classes, those in GSS 1 to SS3, as well as those from primary 4 to primary 5 to primary 6. So this is to enable them to have a good and better understanding of mathematics so as to improve their knowledge on sciences and other aspects of other discipline that has to do with mathematics. Because if you look at what is happening now in our educational system, most kids are scared of mathematics, and with this you discover that they will have more confidence in mathematics and they'll excel better in life. I pray this helps them, because this is just a free class for them. You can also watch a replay of the class session. Then if you want to also partake in the conversation where I have to call you, then you have to subscribe to that package where we have a one-on-one discussion with you. Otherwise, you are to view and interact with us using the comment section. So thank you for being patient to the end of today's class. See you in our next class come tomorrow by 7 p.m. Do have a nice day.